So in your chem-R&E projects, you're gonna be explaining how the chemistry works in a particular reaction or set of reactions related to your topics. If you think about the rate of heat of neutralization, you're going to be talking about acid-base reactions, acid-base neutralizations, right? And as we may have talked about in class a little bit, there's very simplified versions of that. Oh, you put an acid and a base together, you get this or that, whatever, right? That's certainly important to include that kind of information in your discussion, right? And that's the way a lot of people talk about chemistry reactions. They say, oh, well, you put these two things together or three things or whatever together, and out comes these other things. Maybe it gets hot, maybe it gets cold, maybe it doesn't do either. That's great. That's a good start. But the way we want you to reach into the details of the science, what's going on, is to try to describe what's going on at the molecular level. What kind of interactions are the molecules having in the different compounds, either elements or compounds, right? And like in this case here, I'm just going to show you a couple diagrams to give you an idea what I'm talking about, right? Here we have a couple different versions of molecular diagrams for water, right? Everybody knows water is H2O, right? So 2 hydrogen atoms, 1 oxygen atom, right? And here's a kind of one sort of three-dimensional model of it. Here's another one. This kind might be more helpful because in these diagrams and in some of the other ones, you can do a little more illustration of what the bonds look like, right? What type of bonds are they? Ionic bonds, covalent bonds, or what have you, right? Now, the other thing that's really good about seeing this kind of a diagram, as you can see, it's not totally symmetrical, right? You've got your hydrogen atom sitting off to the side, and the oxygen atom sits up here, so they're not perfectly symmetrical around that oxygen atom, right? And thus, this helps to explain how a water molecule is polar, right? But don't worry about that right now. If your topic may or may not involve that aspect, somebody doing the paper chromatography are going to be very concerned with polarity, right, in their things. Anyhow, so here's an example of a molecular diagram, right? And if we were talking about what happens when reaction happens, when different chemicals interact, you're going to be talking about breaking bonds and forming new bonds, right? And so this is the kind of thing that's going to help you do that, understanding the shape that's here and explaining that as part of your background science. Here's another. I thought it'd be nice just to see a couple different molecules. HCl is very simple, right? HCl, a hydrogen and a chlorine atom. HCl right here, and we use it to make hydrochloric acid, right? And that's a very simple one. The nice thing too here is that in this instance here, we're seeing that the hydrogen atom is much smaller than a chlorine atom, right? Of course, that has to do with that atomic structure, which for a hydrogen atom is very simple, right? Here's another one. This one's really cool because it's showing how the different atoms relate to one another. Also illustrates different bonds here. You got one type of bond here, a different type up here, and so on, right? This is H2SO4. I'll switch this to the next view here real quick. Okay, H2SO4, so the two hydrogens out here and here, right? Sulfur here in the middle, and 4 oxygens like this, right? And so this is, again, this is you take, a bunch of this in a solid form and dissolve it in water, you get sulfuric acid. Hydrogen sulfate dissolved in water is sulfuric acid, right? So again, it's very handy to be able to see how these different atoms are arranged in relation to one another. It's also good for you to talk about the types of bonds, and finally then how the bonds are broken, or which bonds are broken when, and how they reform in the products, the output from the reaction, right? And we'll look at then the molecules that are formed when the reaction takes place, and you get your products, okay? So as you're thinking about your background science, right, the next assignment you've got to do after the two that are due this week, the first journal check and the interview questions, right? Which, of course, the interview questions are going to help you along the way to get to your background science understanding and explanations, right? So your background science then becomes a fairly in-depth explanation of, what's happening in the reaction, all the different things that are going on in the chemical reaction. You'll also talk about, why anybody cares about this kind of reaction, why study it, right? What is the purpose? And even if it's like the thing says we're finding the amount of calcium in milk, well then do tell us about why we care about the amount of calcium in milk. Is there some reason that's important, or like the vitamin C in orange juice, stuff like that? Well, why do we care about that? Why is it important? So be sure to include that in your background science. And your background science then becomes an important part in your final report, which is your introduction in the final report. Okay? So hopefully this clears up the kind of detail we want you to go into in your descriptions and explanations. Okay? And of course, you feel free to send us any questions that you have. Thanks for watching.